Hi, welcome back to LeetCode. So in this video, I am going to discuss LeetCode problem 3584, maximum product of first and last elements of a subsequence. So you are given integer array nums and integer m. Okay, return the maximum product of the first and last elements of any subsequence of nums of size m. Okay, so we actually have some input array nums. So now we have to generate a subsequence of length m, and for each subsequence of length m, we have to calculate the product of the first and the last element. And now we have to we have to return the maximum value of this product, first and last element. So that means, suppose we actually have 1 2 3 4 and m is equal to 3. So first of all, we have to generate all possible subsequence of length 3, that is 1 2 3, 1 2 4, 1 3 4, then 2 3 4, in this way, right? These are all possible subsequence of length m. That means m is equal to 3. Now, so for what is the product of the first and last element, that is 1 into 3. This is 3. Similarly, for this subsequence 2 into 4, this is 8. For this subsequence 1 into 4, this is 4. For this subsequence, this is 1 into 4, this is 4. So out of all of this possible subsequence, what is the maximum product? This is actually 8. So for this subsequence and m is equal to 3, the answer will be 8. Got it? This is clear. Now let's see the example 1. So this is the input array and m is equal to 1. So what is the possible subsequence possible of length m? That is, one is -1, another is -9, another is 2, another is 3, another is -2, -3, then 1. So this is all possible subsequence of length 1. So for this subsequence, what is the first and last element? -1 into -1, this is 1. For this subsequence, first element is -1, also last element is same, this is actually 81. So you can see that in this actually the maximum value I will get, this is 81. So that's why answer is 81. This is clear. So what is the brute force approach actually we can think? So first of all, we can think that first of all, generate all possible subsequence that is possible from the input array of length m. Now actually I have list of all the subsequence of length m. Now I will iterate each subsequence and I will check what is the first element and I will multiply with the last element of this subsequence, and I will calculate what is the product of this, and I will compare with the answer variable ultimately. So to generate all possible subsequence, so what is the time study for that? Because each number actually have two options, either it will be part of the current subsequence or it will not be part of the subsequence. So for each number actually have two options. So this will take 2 to the power n. If there are n number actually total length of the input array is n, then each number actually two options. The total number of subsequence in roughly we can actually check that 2 to the power n. So this will to generate all possible subsequence of length m. And suppose there actually x number of actually subsequence are possible whose length actually is length m. So I have to iterate each subsequence and I have to check what is the first element of that current subsequence, what is the last element, and I will take the multiplication of that value and I will compare with the answer. So ultimately you can see that the time study will be roughly exponent 2 to the power n. This is maximum value, correct? So this will not actually work. So now how can actually solve this in better time study? So this actually, like, first of all, let's see how can actually do that. So suppose actually I have x1, x2, x3, x4, x5. 5 element is present. Now our m is equal to 3. Okay. Now I want to fix this. This x4 is our last element. I fix that. So what is the minimum subsequence I can generate from here? Length is equal to 3. So this will be actually x2, x3, x4. This is actually the, if I actually take 3 consecutive numbers, then it is the minimum subsequence I can actually generate of length m. Now what is the first element for this? This will be x2. So the multiplication of x2 into x4. Now another actually I can do that x1, then I can actually take x3, x4. Okay, then what is the first number? That is x1, last number is x4. So this will be x1 into x4. This is clear. So the rightmost first element I can actually take that actually x2, correct? And this actually all possible 0 to this x2 means x1, x2 all are actually possible. First number actually I can actually take. I don't need to check what is the middle number, second number, third number, fourth number. I have to check only the first element and the last element. Last element I have already fixed. Now I have to know what is the first element is possible. So I have already fixed this. Okay, it rightmost actually first element is possible as x2 because I need actually 3 element. So this is the smallest range I can actually generate a subsequence of length 3. So that's the rightmost or the rightmost first element is possible as x2. Clear? So I will check that x2 into x4, then I will check x1 into x4, then suppose x0 into x4. In this I will check all the possible product for each last number. Like here I fix the last number x4, but here to the first number actually not changing, only the first number. So for each last number, I am actually checking with all, compare with all possible first number, correct? So for that the time schedule for each last number, I am actually comparing all possible first number is possible. So last number is possible j or I, it is possible to 0 to n minus 1, suppose roughly. So only for each I, for each last number I actually have, I have to iterate from 0 to the range. What will be the range for that? That will be, suppose, let's see one thing, observe one thing, x1, x2, x3, x4. So this is the index 0, 1, 2, 3. So this is our last element and m is equal to 3. What is the rightmost actually index I can actually take? This is actually 1. Rightmost mean the rightmost first element. So this is actually 1. So current index is I. So that's actually 3. And I need actually 3 element and plus 1. So now what will be the rightmost index I will get? That actually 1. Now you can see that the rightmost index I will get 1. Clear? For the rightmost first element it can be 1 only, maximum 1. So the range will be 0 to 1. So that means the first element, the range of the first element, it will start from 0 to the current index I minus m plus 1. Clear? So this is for each I, or for each last number I will compare with all possible first element. So the times will n into n roughly. So this is for last number. For each last number I have to pair up with all the possible first number. So that's why the n possible, roughly n first element are possible, n number of actually first element are possible. So that's why it will take n square. So it is better than the first the brute force approach, but it will not give us it will not pass all the test case. Why? Because here n is equal to 10 to the 5, so it will be 10 to the power 10, so it will be greater than 10 to the power 8, so it will give us TLE. Clear? Now I can use this concept in the optimal approach. How? That means I know that we have to fix the last element, correct? Now for each last element, what I have to do? I was checking that what is the first element possible. Now I have to compare. I actually just, what I'm doing, I just pair up with the j comma I, j1 comma I, then j2 comma I. In this way I was trying to pair up with all the possible first element, and I will compare what is the maximum value I can actually get. What is the maximum value? What is the maximum value? Now you can actually what is the ultimate loading? We are actually taking all the maximum value. So if I somehow already store that, I know that for 0, 1, 2, 3, 4, 5. So this 4, if this is our I, the last element, and m is equal to 3, the j will be, the maximum rightmost j will be, that will be I minus m plus 1. So that means 4 minus 3 plus 1, that is 2. So 2 is the rightmost index. If I already store what is the maximum value till here, if I multiply only with that, so I know, suppose actually the maximum value here is x, suppose, and I know the current number, nums of I. So if I multiply with x into the current number, so that ultimately what to do, we are actually pairing up with the all the possible, like I am trying to pair up with this x1, this x2, then x3, means x1 into I, then x2 into I, then x3 into I, right? In this actually I am just checking all the possible first number, but if I already store what is your answer, that will be give us the minimum maximum value. So that means whatever the x1 or x2 or x3, whatever the maximum value, that will actually multiply with current number, that actually give us the maximum value, maximum product. So that's why if I ultimately store what is the maximum value, that is just x, suppose this is store all the maximum, the ultimate maximum value till 0 to 2. So ultimately then actually easily I can multiply with x into the current number, nums of I. This is clear. How can I actually optimize this? Because ultimately we are checking all the possible x1, x2, x3 in this way, one by one, correct? Then I will actually taking the maximum value out of this. But if already what will be the maximum answer? Suppose x2 is the maximum answer, x2 into I, it will give us the maximum answer. So ultimately that means what? This x2 is the maximum value, x1 is greater, means x2 is greater than x1, and x2 is also greater than x3. This is clear. That's why this actually multiply will give us the maximum result. So that's why if I already store the maximum value till 0 to this index 2, I will easily get out that this is our maximum product, so I can generate. So this is to prefix, or you can say the prefix max. In the left side I actually already store what is the maximum I can actually generate, maximum value I can actually have till index 0 to 2, something 0 to I can easily actually fetch the value. Now I also store the minimum value also here. Why? Prefix min. Why? Because they actually allowed the minimum value also here. So that means I actually have, suppose here actually I have seen the minimum value, actually I have seen -10. Suppose currently I am here, we actually have some element in between, and here actually the value is suppose -50, and all the number actually here is positive, suppose 1, 2, 3, 4. So if I actually multiply this 50 into 1 minus 50 into 2, in this whatever the value I get, and if I multiply this -50 into -10, then it will give the 500. So it will our maximum answer, correct? It will easily better than -50, -100. So this should be your answer, expected answer. So that's why to handle this such situation, so that's why I have to handle also the minimum, I have to store the minimum value also till 0 to I, correct? Clear? So first of all, generate or the calculate the prefix max and prefix min, all the numbers for 0 to n-1. So I can easily say that from 0 to I, what is the maximum number actually I have, in 0 to I, what is the minimum value actually I have. I can easily actually fetch the value. Now for each last number, that will be the similar for the previous approach also, in the case of the big of n square, that is the better approach. So for the each last number, I know that what is the rightmost first element is possible, rightmost first element. So that will be I minus m plus 1, correct? And for that index I can easily fetch that what is the max of this particular index. Suppose this is index as x, max of x, and what is the minimum of x, and what is the of two subsequence I can generate. One is with the maximum subsequence, means positive with positive. I can assume this is positive. So this will be something, suppose this value is a1 and this is a2. So a1 into nums of I, another is a2 into nums of I. This is clear. These two options are possible. Easily, I don't need to check all the possible first numbers. So actually it is actually take big of 1 to check the first maximum first element. Got it? How to optimize this from big of 1 to big of 1, big of n to big of 1 by using the prefix sum, or you can say the prefix max or prefix min. Clear? And ultimately this will take big of n only. one big op needs to calculate the prefix max and prefix min. Another big op needs to for each last element I will easily calculate what is the maximum first element or the maximum product I can generate for each last number. Got it? Now go to the code. You have any suggestion, any comment, you will comment on that, and I have shared that this code in the description. You can check all that also. Now go to the code. So n is the number of actually length of the input array, and the answer will be I will start from minus infinity. And if m is equal to 1, that means what? M is equal to the corner case. That means the first element and the last element both are actually same. I do not need to do anything for m is equal to 1. So that's why for m is equal to, what I do, I'll just iterate all the numbers, and for each number I'll just multiply with the current number, nums of I into nums of I. Clear? And I will store this with the answer, ultimately return the answer. Clear? But if it is greater than 1, m is greater than 1, that means we have at least 2 elements. So we have some option, different option for first element, because the first element will not be never be equal to the last element. If m is equal to 2, m is equal to 3, because we have some element, correct, that is not equal to the last element. So that's why for m greater than 1, what to do, I need two variable, two vector. One is to prefix max to store the maximum value I have seen from 0 to I. Another is for prefix min to store the minimum value I have 0 to I. Correct? Why I need to extra this prefix min? To handle the negative case also. Correct? And for prefix max, the index 0, it will start from, because there is no element in the left side, it will be equal to num 0, and prefix min also equal to num 0. Clear? Now it is start from I is equal to 1 and I less than n. So for each number 1 to n minus 1, I have some element in the left side. So how can I easily find out? I don't need to check all the numbers on the left side. So I have already stored the maximum value. I have 0 to n minus 1 in the prefix max of I minus 1 index. Clear? And I know the current element nums of I, and I will take what is the maximum value and I'll store the prefix max. Similarly for prefix min, I know that what is the minimum value I have seen in the index 0 to I minus 1. So how will I will check from the prefix min of I minus 1 index, and I know the current element nums of I. It may possible the current number is the minimum element, so I will take the minimum value and store this in the current index I. Got it? So after this for loop, I have actually stored the created two vector, prefix max and prefix min. One is to store the, I can easily say that what is the maximum value I have 0 to I, and another prefix min, I can actually easily check that what is the minimum value I have from 0 to I, any random index. Now I am starting from 0, the last element. I am actually fixing the last element of the subsequence, and I will check the what is the rightmost first element is possible. Then I will check what is actually the pair are possible, alright, maximum product. So that's why I is equal starting from m minus 1. Why m minus 1? Because I need actually at least m element to generate the subsequence. So that's why the last element it can start only from m minus 1. Then I can actually have some m elements, at least m elements to generate m subsequence of length m. So that's why the I is starting from m minus 1 and I less than n I plus plus. So I actually have two options. One is to generate a subsequence with the maximum value. Another is the minimum value, because it is possible the current number is the minimum value, means the current number is suppose minus 50, and the prefix the starting the rightmost starting element actually I have maximum value as 10 and the minimum value actually I have minus 20. It may possible. So I should actually generate all the possible. So two pair are possible. One is the 10 with current element. So current number actually is minus 50, and prefix the rightmost actually that actually I have that is 10, and the minimum value actually I have 20 minus 20. So I can actually generate a subsequence 10 with minus 50, another is minus 20 with minus 50. Correct? Because I do not need to check what is the element present in between 10 and 50 minus 50. So I only need to check the 10 and minus 50. So that's why one possible product will be 10 into minus 50, that will be minus 50 minus 500. Another is minus 20 into minus 50, this is actually positive 1000. Clear? This is our maximum answer. So that's why I have to store this. So that's why I have to do two operations. Option 1 is to multiply with the prefix max of the particular index I minus m minus plus 1. This is the rightmost index. The rightmost first element is possible at So I minus m plus 1. I already explained why. So this is the index of the prefix max, and similarly for the prefix min, one with prefix min. So I'll have two option, one option two. So out of these two options, I have to take one maximum value that will actually I will get, so and store in the ultimate answer variable, global variable, a return answer. Clear? So thank you, and if you like the experience, please like the video, and if you not yet subscribed, please subscribe channel. Thank you. Bye.